Welcome to Elixir Mix, your weekly Elixir podcast talking with members of the community. My name is Mark Erickson, and on our panel today, we have Eric Ostrich.
Hello.
And Michael Ries.
Hi, Elixir friends.
And today we're joined by our special guest, Jon Carstens. Jon, say hi.
Howdy.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
And Michael, I understand you and Jon have worked together before?
Yeah, so Jon and I worked together for a couple of years at a company called MX. And while we were there, I was an oppressed, poor soul trying to fight for Elixir adoption and losing that battle. But along the way, me and Jon started hanging out and doing Elixir stuff together. We built a NAT connector together a little bit, and then we were doing some build process things where we had a team of C++ developers. They would update the app, and we would rebuild it and send it to bunches of devices. And so all those devices would hold a WebSocket connection open. That's something that Elixir is fairly good at. And so we worked on some stuff like that together. And then subsequently, Jon moved on and is now working at SmartRent with Frank Hunleth doing some really interesting Nerve stuff. So Jon, do you want to give us just a little bit more intro of what life has been since you arrived in the promised land of working with Frank Hunleth?
It's surprising. It's very, very entertaining and full of adventure, that's for sure. So we work with smart home devices, but basically for rental properties. And we're in the process of kind of collecting all of this communication to a single hub, which we build and use Nerves on. And then we use NervesHub to deploy and manage all these that are in apartments and other places. So there's tons of adventures there in trying to deal with nuances of both hardware and Erlang and Elixir.
Nice. I know Justin Schneck's keynote at ElixirConf that was just over. He talked about, so that SmartRent is one of those companies that's mentioned like in the top 3, with Latote and the FarmBot, so it's one of those kind of, you guys, sounds like you guys have been using it for some time. And yet are you, that you've been contributing and being part of that Nerves community, right?
Yeah, correct.
Yeah, Jon actually helps to organize the Nerves remote meetup that we've mentioned a few times on the podcast as well. So I think you were doing that before you went to SmartRent. Is that right, Jon?
Yeah. So we've been doing that meetup since I think last August, right? If I'm remembering correctly. And I joined SmartRent in March, so had a good little while of just toying around with Nerves on my own before actually miraculously finding a job to work in it full time.
Yeah. Can you give us a little bit of info, Jon, on what parts of the Nerves ecosystem have you been working on since going to SmartRent?
I have been doing a majority. I should say a good amount of my time has been spent in NervesHub. So in managing collections or groups of devices and being able to interact with them remotely or do firmware updates. And then, so a very high level there, but then a lot of my time has been spent in very low level stuff, like in things like ShoeHorn, which is controlling basically app start order, and the Erlang heart module to control like automatic reverts if the firmware fails or something like that, where it gets a little more into how the hardware is booting up and how to control that and harden it and make sure like we can keep that true Elixir Erlang stance of reboot or, self-correct. That's the word I'm looking for. Just to make sure, when we're deploying devices out in the field, if anything goes wrong, we want to reduce the amount of time, or we want to restrict anybody having to go out and touch the device. So I've been doing a lot in that area of how to make sure it can recover, or at least get to the firmware update server. So if it's bad, we can communicate with it, and lots of interesting stuff in that realm.
I would love to hear about what kinds of devices you guys are deploying for SmartRent. That these, we hear about it in the presentations, like, oh, you guys are using these remote devices to help either manage or collect information and data. I'm just curious, like, what kinds of devices, what kind of purpose are they serving for the business?
So if you've ever worked with smart home stuff, there's lots of different brands, and you can buy lots of different things, but not all of them really connect to the internet. They use protocols like Z-Wave or Zigbee, and then subsequently they have to have some sort of central hub that does the communication out to their services or on the internet or something like that. And so at SmartRent, because we're dealing with lots of these devices, to avoid having to have a bunch of different hubs and to support lots of different brands, we have built our own custom designed and built hub board, basically using a BeagleBone Black Octavo chip, and with the necessary communication modules, and then that becomes the central point in which we communicate with all these other devices. And so when we're talking about what we're deploying and having in the field, it's basically those hubs to do that amount of communication with other devices, or things like light bulbs or locks or water leak sensors, things like that.
So does that mean those like water leak sensors, smart locks, those are basically existing products manufactured by someone else, but you just make them all connect together and kind of give a centralized place is it for the property managers or maybe for the tenants as well to be able to see all the information from those devices? Right.
Yeah. So it's a lot of, we're not really building those components ourselves. So it's a lot of pre-existing things with brands, like Yale or Schlag or Zapato, stuff like that. Existing, maybe Philips bulbs. I don't even know if we have any of those. But anyway, regardless, yeah, it's all pre-existing, and it's targeted for property managers and tenants and property owners. So there's an aspect of it where the goal is to have systems in which property managers can easily interact with a vacant property to get a feel. So when you have door locks or other things or thermostats, you can do showings and stuff without having to have a bunch of staff present to schedule times. And then when tenants are there, they can enjoy those smart home features to use an app that we have to unlock or control blinds or other things like that. And then there's an aspect or an asset management part of it where the leak sensors or smoke detectors or stuff like that will come in handy, or even thermostats. The company is based out of Arizona, so there's lots of places in Arizona using this, and you don't really want it getting too hot while it's vacant, right? But you don't want to waste a ton of energy. So there's areas using that, and if nobody's in there, it's nice to have a leak sensor in case water goes everywhere. You want to know about it. So we designed around a lot of those and existing components and functions.
It's very cool. I can see a lot of value for that. So I know one of the other things that I was really impressed with, coming back to Elixir Conf. So you were there, but you gave a lightning talk, which we're gonna come back to and talk about in a little while. But also during Justin Schneck's keynote, where he was talking about NervesHub, a lot of the interesting, cool stuff, he talked about and showed off about halfway through the presentation. I have a link in the show notes with the timestamp, so you can jump into that if you'd like. But that is where he starts showing this IEX style console into a Nerves device. And I understand you had something to do with that.
Yeah, that was way fun. I think it was at the previous Elixir Conf that this idea came up, and Connor, in his true fashion, the idea was prompted, and so he built something really quick. And months went on, and then I joined SmartRent, and I was working a lot at NervesHub, and they say, hey, remember this idea and thing Connor had? We should add that. And so they basically tasked me with it. And I went through helping build it, and it's actually very interesting. I guess you want me to talk about the I/O?
Yeah, I would love to hear a little bit about how do you actually get like the prompt from the device through the internet, down the other side of the internet to my browser. And then when I type something in, how does that get back to the device again?
Oh yeah. So I'll preface by saying this is all through Phoenix channels. But IEX itself is, no surprise, just another process with certain code or controls loaded into it. And it just works directly with I/O. And the way I/O works is it has what's called a group leader. That's basically, I don't know, I guess you could call it a supervisor, but not quite. The group leader is like the manager that is managing groups of processes and I/O processes and the message handler. And so when you open up other I/O ports or I/O streams, they're all going to be sending back and forth between this group leader, and the group leader itself is going to facilitate what to do next with those lines. And so it's a constant back and forth of I/O saying, okay, I need you to draw this line, and the group leader saying, okay, I drew it, here's what happened after that line. And this this exchange back and forth. So what we did in NervesHub is the group leaders usually handled by Elixir or somewhere else, or by a terminal process or something different. But we used the socket connections to NervesHub, and which is basically another gen server that we'd spun up, and we start an IEX server, which has a little simple API to just say IEX server.run or something of that sort. And then we assigned that socket as the group leader, that little gen server as this group leader. And so now we can handle all the messages coming in back and forth and decide what we want to do with them. And in our case, we want them to go to NervesHub. So we send it up the socket up to NervesHub, and then we have a bunch of channels and broadcast messages and all that stuff on the web UI to print the lines that it's given. And then when you need to submit a line or you need to add an action, we send that back down. And the socket channel that's now the group leader on the device knows how to reference that back to the I/O and server running.
One of the biggest pain points that I find as I talk to people about software is deployment. It's really interesting to have the conversations with people where it's, I don't want to deal with Docker. I don't want to deal with Kubernetes. I don't want to deal with setting up servers. I don't, all of these different things. And in a lot of ways, DevOps has gotten a lot easier. And in a lot of ways, DevOps has also kind of embraced a certain amount of culture around applications, the way we build them, the way we deploy them. And I've really felt for a long time that developers need to have the conversations with DevOps or adopt some form of DevOps so that they can take control of what they're doing and really understand when things go to production, what's going on, so that they can help debug the issues and fix the issues and find the issues when they go wrong and help streamline things and make things better and slicker and easier so that they'll more generally go right. So we started a podcast called Adventures in DevOps. And I pulled in one of the hosts from one of my favorite DevOps shows, Nell Shamrell Harrington from the Food Fight Show, and we got things rolling there. And so this is more or less a continuation of the Food Fight Show, where we're talking about the things that go into DevOps. So if you're struggling with any of these operational type things, then definitely check out Adventures in DevOps. And you can find it at adventuresindevopspodcast.com.
So that was actually the easy part, believe it or not. It was a lot easier to get running and get this
Nice.
the separate IEX server process running and sending messages back and forth. The hardest part was the ASCII characters that you have to then display in the NervesHub web UI. I would say that's where I spent most of my work on, just making that work.
Do you mean like the ASCII characters for getting the console highlighting, or like the colors, or is it something else?
Yeah, colors, anything. Any ASCII character you have to transpose into what you think the HTML counterpart is.
Oh, wow. Yeah.
And so,
Yeah.
and it's basically sending you one line at a time. And then we take each line and we print it out on the console, or we have to transform it, and then we print it out, and we're doing that on the fly as messages are coming in. And there's some crazy, I learned a lot about ASCII coloring and characters doing this.
I'm guessing binary pattern matching was very helpful.
Yeah. In this sense, I didn't do a lot of that actually. I did a lot of recursion
Mm-hmm.
because an ASCII, when it gets colored or something, there's usually a start point, then it goes for a certain amount of time, and then it ends. So I did a lot of. There was actually a library that I found where a guy had done some of this, and it's called ANSI2 HTML, and that's what I took and then just adjusted to fit all the other edge cases that we needed. But it does a lot of recursion and finding those start points and then chunking, groups of text that seem to be colored based off these start points and goes off of that.
Stuff that I can fully take for granted because you've done all the hard work and I can just use it.
Yeah, for sure.
One question I had as you were talking through this, something I've never bothered to look into, so let's say somebody has opened up an IEX session through NervesHub, and so you have an IEX server running on the device. If I then locally connect to that device, maybe over SSH on Wi-Fi or something like that, am I seeing that same IEX server? Is it like a registered named process that I'm going to then be in that same terminal session, or do you have multiple IEXs running at the same time? How does that work?
So in this case, it's multiple. So if you were to SSH in and have it running in NervesHub, you're actually into two different IEX server sessions. And, I don't think I've ever thought about trying to do a named registry or start an IEX server as a named process. So I don't even know if that's possible. That'd be cool.
Next feature request. It's like the Murphy's Law of feature requests. Whenever you think, oh, I never wondered if this is possible, that's the day you're going to hear about it.
Yeah, exactly. What is interesting, though, is that if you were to open up multiple tabs for the IEX session to the same device, you will actually be into the same IEX session because it's on the socket and we're making sure we're not starting 100 different IEX servers so we don't accidentally forget about one, and now you've got processes and memory full up on the device because you've gone to remote session. So each new tab joins the same socket process, which is holding a single IEX session. And in fact, if multiple users are doing it, it's tagged by username, so you can sit there and almost pair on working on the same device and send commands to each other, and you'll both get the same output. If for good or for better or worse, it's cool. You could do that there. I don't know if that's maybe the best use case, but that was fun to put in nonetheless.
So I imagine this feature is a pretty powerful thing for being able to debug. I imagine it's equally helpful for me to debug when I have the device next to me, but it's super powerful when it's already deployed. Have you seen that be a benefit to your devices and your deployments?
Oh, absolutely. So I was mentioning before, a lot of the work I was doing was to make sure nobody had to physically go to a device if there was an issue. And so a lot of that work is to make sure that the startup of connecting to NervesHub is separate from our application and everything else. So no matter what's going on the device, as long as it's got power, it will connect to NervesHub. So the firmware can be totally busted and borked. And if it's connected to NervesHub, we can get in, we can look around some logs, we can decide we want to push a new firmware to it or something like that. But it definitely has helped, especially, so even amongst my team, we all will have development hubs and boards. But there's been quite a few times where something's not working right, and it's not really areas that I've been working in. And so somebody else will get on and remote IEX and be able to get in, and I don't have to set up SSH or weird networking ports or opening stuff around my network or VPN. It's just easy and go to.
Your comment about pair programming in an IEX session reminded me of in high school when a friend and I found out, I think the command is called wall in Linux. You can send messages to other people on the same Linux host. And that's all we did for weeks. We didn't learn anything else about computers after we knew that command.
Yeah, this last session, I was working with Matt Ludwig's on some stuff with our boards, and he was throwing out messages as atoms or strings every now and then to and we've got Slack open right here, but for whatever reason, it not only became a tool to work with the device, but almost a new communication port where, I don't know what's going on. I don't either. Try this command. Boom.
That's great. Just like typing it all in the console there.
Yeah. I should also preface while the remote console is pretty neat, it was very much created by backend developers. And so I have, it doesn't look the most pretty. The input line is slightly offset. And after battling with CSS, I just gave up. There's no tab completion. So there's definitely lots of work that could be done on it that someone with a little finer comb could come in and really clean up. But currently, in its current state, it's still very useful, very helpful, even with the little quirks that are there.
So is that a request for contributions?
Oh, absolutely. Anybody can come contribute.
Where do people go to see that? Do they just go to the NervesHub GitHub page?
Yeah, so there's a Nerves-Hub group. This specific implementation is within the NervesHub web repo. And the counterpart, there's also a library just called nerves_hub, which is basically the client that you put on the device. And those two in conjunction are doing the communication back and forth. But the web UI would be in that NervesHub web repo.
Cool. All right. I think I found the right one. I put it in the show notes.
Mm-hmm.
All right. Well, before we run out of time, we would love to talk about the lightning talk that you gave, which I think is just fun because, as developers, as geeks, we recognize when we're over engineering something, but that doesn't mean it's not fun. It doesn't mean we don't find value still. And so we'll certainly have a link to the lightning talk and the article that you wrote up about it. But I'd love to hear about what this problem was that you encountered and how you thought you'd over engineer and have a fun solution.
Okay. The problem I encountered was at its root, laziness and frustration. We had a really old ceiling fan that died, so we bought a new one. And of course, because of my affinity towards technologic things, I said, let's get one with a remote. That would be cool. And then we could control it from lazily in bed when I'm tired. But it proves to be very uncool because the remote frequently gets lost. Kids grab it. I don't even know why. Or the state of the fans is not controlled by the switch. So if the light was turned off and the remote is lost, flipping the switch does nothing. So it just became oddly and surprisingly cumbersome to try to manage. So then I discovered that it just uses radio frequency and it was nothing really special. And that just started down this foray into learning about radio and what devices use it, how to interact with it, and down to this effort of discovering how to solve it. So the lightning talk I gave was titled Nerves at 434 megahertz. So because I discovered it was radio and because I really enjoy working with nerves, my end goal was I need to figure out a way to integrate this with my existing hardware and nerves. And we should probably preface and warning that most things in your household that are controlled by radio are in that 300 to 430 megahertz range, which is technically a restricted band in the US. But there's a billion little rules about it. But basically, within the confines of your home or within a few meters broadcasting at 434 megahertz, you should be just fine. But if you're sending it out miles, somebody's going to get mad at you. You might go to jail, and it won't be my fault.
So I'm guessing then your little broadcaster, you want the signal to be pretty weak then, so it doesn't go very far. Yeah.
So my transmission device is GPIO pin 4 on a Raspberry Pi with a jumper cable. That's it. There's nothing special about it.
I just have to say, this is the best disclaimer I've ever heard on a podcast ever. If you do this and you do it too much, then you will go to jail and it's not my fault. That's when you know that this is a good idea.
Yes, absolutely.
So for people not familiar, a jumper cable literally just means a small wire. You can buy bundles of them on Amazon or other electronics sources for a few dollars for a couple hundred of these little wires. And they're just really easy to connect and disconnect from the pins on a GPIO. You can just push them on and they press fit basically into place. So John, does that little wire basically it just becomes a small low power antenna?
Yep.
Hmm.
Yeah, so you could get real scientific about it, and you could measure out an antenna, the length of antenna you need for the exact frequency you need to get good broadcasts out of it or something, and coil it and get all fancy. But for my use case, I just plug in a jumper cable. And I don't even care. It works. It works from corner to corner in my house, so it's good enough for me.
We've been recording Ruby Rogue since 2011, and we've talked to a lot of people who have had a really deep influence, not only on the programming community, but also on the Ruby community. And as we've talked to these people, it's become apparent to me that we talk a lot about the things that make them interesting that they've done, but we don't really get into how they got into programming or how they came up in their career, how they got to be the person who invented whatever library or technique that they came on the show to talk about. And so I put together a show where we actually highlight these things. We talk to them about how they got into programming. We talk to them about how they got into Ruby, maybe how they got into Rails. We get a little bit deep into what makes them tick and why they are the way they are. And then we talk about what they're working on. We talk about the things that make them well known or make them interesting. And a lot of times it's the stuff that goes beyond the code that really makes these people tick and makes them the kind of people that we want to hear about. And so I put together a show called My Ruby Story. You can find it at myrubystory.com. And it's where I interview these people and just get the stories of these people and how they came into programming. So if you want to hear inspirational stories or get ideas on how you can actually advance your career, then go check it out at myrubystory.com.
So then is the grand vision of this device that you'll have it in your bedroom as a stationary thing with a big button on it or something?
So what I actually did was two-part. So I have many projects like this. I basically have one Raspberry Pi that's hosting lots of implementations for all these projects. And I actually gave a talk at MPEX New York about most of these. And so I have this in my basement, and I have this website that I use at home. And I guess I should get into the premise of it. Because it is radio frequency, it's just a really simple signal. And there are lots of easy ways you can record it, which is in radio terms called a replay attack, where you try to record a signal and then you decide to replay it back at a different time from a different device to copy what's going on. And so what I had done is recorded the signal of every button on this remote. And then I made this little library, which I present at the talk. It's basically not required. It could be used as a starting point. It's called a replex. People don't have to use it, but it's just a compilation of here's what I did in order to replay these signals back. And it includes binaries for another project I found called RPI-TX, which is a guy who has done lots of crazy work to make a Raspberry Pi be able to transmit between, I think it's 5 kilohertz to 1500 megahertz range, something like that, just with a single GPIO pin. And so I recorded all these signals with another device. Oh man, we're like getting deep into the woods here. There's another device called a software-defined radio dongle, or SDR, and that can be used to listen in on radio signals. Like it's actually a very powerful device, and it offloads a lot of the work of dealing with radio signals into the software instead of the traditional hardware. And so you can get this little really small USB device and antenna and get a really wide range of radio signals in which you can watch in on, or you can listen to radio on it if you wanted to. Or in my case, I used it to record signals of my simple fan remote. So once I got all that, I have it on this little Raspberry Pi. This little Raspberry Pi then just has simple functions that will blast the signals that I want to turn the fan on or off or turn the light on, all that jazz. And I have a web page that is now on my phone that I use to control the buttons and stuff for the remote.
Have you, John, found any technical solutions for the problem of children wanting to steal remote controls? Because that is actually a general class of problems that I can't seem to solve in my life.
All right, I've got an idea for that one. So you have some dummy remotes that are sitting around and they're electrically statically charged, so they shock when you touch them.
Kids are too smart, man. They know that they're not the real thing. So my current solution is so I've got all the radio remotes covered. Anything in my house that has a radio or that use RF or frequency on the remote. I now have that all copied and onto this little Raspberry Pi. So now I'm working into infrared, and maybe I'll have something more on that in a month or two. But trying to replace,
gosh.
my current goal is replacing all remotes in my house with my phone and my voice. And right now I have that working for radio.
Very cool. Well, we will have to get an update on that so we'll be pinging you every day in 30 days to find out what's going on with IR. Well, that sounds fun. Well, that's probably a good place to wrap up. Is there anything else we want to touch on? Make sure we talk about before we go to picks. All right. Well, let's go to picks. Eric, do you have something?
Sure. So inspired by the talk today, I've got 2 picks. The first one is it is a ANSI parser in JavaScript. So I've also dealt a lot with ANSI escape codes from Telnet games, but it ends in the same place of like a terminal. So this is there's no docs for it, so you'll have to like dig around a bit, but this is used in my side project Grapevine. That there's a web client that takes the Telnet data, shoots it to your browser, and then the browser actually parses it. So I went the client side instead of I think NervesHub is doing it in the server with live view stuff. So this is a different side of that. It's kind of interesting to deal with because there's a lot of like state machine things you have to deal with, because it's like turn on background green, and then like 5 letters later turn on like foreground white, and then eventually like later on it might reset or change colors. So you have to like deal with all that. So anyways, that's cool. And then we were talking before, we're actually recording about some RC planes, and I was reminded of something called, I think this was it, Real Flight. It's a simulator that has like a little controller for remote control planes and helicopters. So I used to do this as a kid. So it's just cool. Little reminder. Go check it out. That's it.
Nice. Yes. Yeah. So it was cool just like looking at these, the product, and like, it comes with like the RF, handheld device with the little toggles and everything. So you can train your kid so they don't crash your real planes or helicopters. So that's cool. And Michael, do you have something?
Sure. I'll piggyback off of Eric's last pick there. There is a simulator tool called Wings 3D that I'll post a link to. This is a project, I don't know, I haven't heard a lot about it recently, but the first time that I actually started learning Erlang before Elixir was really a thing, this is a project that I heard a lot about. People were having a lot of debates about what things is Erlang fast for and which things is it not fast for. And a simplistic answer that you might hear a lot of times is like, oh, if there's a lot of number crunching, it's not good for that. But someone was posting this as kind of a counterpoint to that. So it does simulation and like ray tracing and things like that, which are very mathematically computationally intensive. But it does it in Erlang. And the reason it can do it in Erlang is because they've picked data structures which are specifically efficient for these types of operations. So anyway, very interesting project. But the other thing I wanted to pick, in the last couple of episodes, I've mentioned a few times remote control airplanes. And I recently grabbed an airplane called the Flight Test Sea Duck. This is modeled after the cartoon in the 90s, which was a personal favorite of mine called Tailspin. You might remember it because there was a huge airplane and a kid would hold onto a little tow rope and fly behind the airplane. That was amazing. Completely doesn't work. Tried it multiple times in different ways, but all of them ending in injuries of some kind or other. But the remote control airplane totally works. And so I've been having a ton of fun. My kids are all having fun. And it's honestly just been a huge chance to spend time outside with my kids doing stuff with their hands. And if the link that's provided there, you can buy like all the things needed, like battery and motors and everything that are right matched to that model, or you can just buy the model if you have some of your own RC stuff. So anyway, it's been a ton of fun, and it's a really high quality model, and I cannot stop singing the Tailspin theme song now. So user be warned.
Man, Michael, next time we get together, it's going to be like story time with Michael, and you're going to tell me all about these crazy adventures you've had trying to windsurf like that. So my pick today is, I saw this morning, Elixir 3.2 was released. and the GitHub changelog is in the show notes. And what I thought was most interesting is that there was a new feature, is support for SQL CTEs. And when I read this, I'm like, I don't know what those are. And so I started reading about these Postgres SQL. It's like Postgres, MySQL. I'm not sure about MySQL, but I know Microsoft SQL Server. They all support these features. And what it is like from the docs, they say, generally speaking, you should only use CTEs for writing recursive queries. Non-recursive CTEs can often be written as joins or subqueries, which have better performance. And the description or example they were giving is, say you have a category that can have, like as a database table, you have categories, and it can have a parent ID, which is recursive and goes to it like a parent, another category. So you have a nested data structure within one table. And CTEs are a good way to navigate that recursively till it reaches the end. And it's like, wow, I didn't even know that was a thing. I'd missed that. Maybe it was a newer feature to SQL. But then, so Ecto now has support for that built in. So I thought that was cool. So that's mine. John, what do you have?
My pick is random because I think that this community would enjoy it. It's a book that I have read recently, and it's called Off to Be the Wizard. And which I think anybody who programs or knows programming or enjoys computers should go and read, especially if you like The Matrix. It's like The Matrix and programmers, but they're nerds and they decide to use it like magic instead. So it's super fun. It's really quirky and silly. And if you're looking for your next book to read, to waste a little time, go check it out.
Yes, John was telling us about that before the call, and it sounded pretty funny and like a good read. And it sounded like it was youth-friendly, so if your kids are interested in Harry Potter or something, it's in that vein. So that sounds awesome. Well, John, I had a lot of fun, and then it was good for us to catch up with you and kind of learn about how some of that stuff worked behind NervesHub and what you've been doing with RF signals and all the good stuff. So if people would like to follow you online or connect with you, where should they go to do that?
Yeah, so you could find my Twitter page. My Twitter account is Jon Carstens, or I'm pretty active in the Slack channels, either in the Nerves channel of the Elixir Slack, or you can join our Nerves Remote Meetup group. We have a Slack channel as well. Has a little bit more history through it. And I guess you can even find me on GitHub, which is JJ Carstens.
Awesome. We'll have some links to those in the show notes. Well, that's it for today. Thank you for listening, and we hope you'll join us next week on Elixir Mix.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com.